Okay, so chapter 3, the derivative. Section 1, the slope of a curve. So you can imagine drawing different curves and wanting to know what's the slope. Well, first, what do you even mean, what's the slope? Well, you can ask for the slope at a point. So if I choose a point, like this point right here, and I zoom in, now near this point, the curve looks like a straight line. And the question is, which line? Because once we find, okay, so if we find that line that approximates the curve is called the tangent line. And the slope of the tangent line, is defined to be the slope of the curve at this point, P. Okay, and now the question is, which line? Like, why should I take that blue one? Why not this pink one? Okay, and so the idea here is that the pink one isn't the right one, because if we pick a point on the curve and let that point go closer and closer, then we're going to get lines through each of those 2 points, and those lines will sort of approach the correct tangent line. Now, how does this actually work? And it's kind of amazing when we figure out how this works precisely, we will also know how to compute the slope precisely using what's called a limit. And a limit is pretty intuitive. You can see that these lines here are limiting towards the tangent line as we take points on the curve getting closer and closer to our point, P. Okay, so just as a recap, if we pick some other point on the curve, let's say this point right here, then if we zoom in on that point, there is a tangent line. And that tangent line has a slope, and that slope we will call the slope of the curve at the point A. Okay, and how do we find that? Well, we take other points on the curve and draw the line between the 2 points, and we let that other point get closer and closer and closer to A. Let's do an example. Find the slope of y equals x squared, that's our curve, looks something like that, at the point 1, 1. Okay, so this is a point on the curve, because when you plug in x equals 1, you get y equals 1. Here's another point on the curve, -2, and what should I put there? Well, if you plug in -2, you square it, and you get 4. So y equals 4 is a point on the curve. And we could find the slope here, and then we could find the slope here, and those will be different numbers. In fact, here the answer will be that the slope is 2, and here the answer will be the slope is -4. Now, how do we get that? Well, first, if we start at the point 1, 1, then move a bit to the point 1 plus h. In other words, here we are, maybe, okay, I have to just draw this a little bit. Maybe this is the point 1, 1. This is x equals 1. And what I'm going to do is just move a little bit by amount h. So this is the point 1 plus h, or x equals 1 plus h. Now above that point is a point on the curve, which is the point 1 plus h, comma, x squared, because our curve is y equals x squared. So what's this point? Or I guess it's 1 plus h squared. Okay, and this point right here is 1, 1. Okay, so we move a bit, and we're at this new point here. Now, the slope is, well, I guess rise over run, or change in y divided by change in x, or y2 minus y1 over x2 minus x1, whatever you call it. In our case, the numerator will be this number minus this number. That's the numerator. It's the difference between that y value and that one. Now we take the x value and subtract this x value. And this will be the slope of the line that is going through these 2 points. It's not going to be the tangent line, but it will once we let h go to 0. Then this point will get closer and closer and closer, and we'll eventually get the tangent line. Now, let's see how that works. This top, we're going to expand it out. Remember that a plus b squared is equal to a squared plus 2ab plus b squared. And I remember that by doing Pascal's triangle and looking at that row. So I get 1 plus 2h plus h squared. That's this part. Now I have a minus 1, and those will cancel. That's my numerator. The denominator, 1 plus h minus 1, is just going to be h. So now I have, what, 2h plus h squared all divided by h. I can divide the h through each of them, leaving a 2 and 1h left over, h squared divided by h. And so this is the slope. Slope, well, it's the slope of a straight line, but it's not yet the tangent line. So how do I get the tangent line? Now let h go to 0. The slope goes to 2. 2 plus h gets closer and closer to 2 when h gets closer to 0. And so that's the answer. The slope of the line here is apparently 2, which means if I step 1, I have to go up 2. Rise over run is 2 over 1, and that's how we get the answer 2. Okay? All right, now how do we do that at the point -2, 4? And I'm claiming we're going to get the answer -4, but let's actually do it. So first, -2, 4 is somewhere over here. This is just my cartoon picture. Now if I move a little bit to a new point, here is -2, and now this point right here is maybe x equals -2 plus h. If I move a little bit in the x value, then my y value will be something else. It'll be, I guess, -2 plus h squared. So this point is -2 plus h, comma, -2 plus h squared. Okay, and those two, really this curve looks something, oops. This curve is curvy between those 2 points. And my straight line I'm going to compute is not the tangent line, but when I then let h go to 0, I will get the slope, not the slope of this line here that I've drawn, which is a straight line between these 2 points, but rather the slope of the tangent line, which will be slightly different. The slope of tangent line. Okay, so let's first calculate the slope of this line, and then we will let h go to 0 at the end. So now we have to subtract the y values. So I get this thing minus 4. What am I going to get? -2 plus h squared is the y value. Minus 4 is the other y value. Divided by the x values subtracted, I'm going to get -2 plus h minus -2. And this -2 will cancel with this +2. And so the denominator will just be h. Now what about the numerator? So -2 squared is going to be 4. Now remember, I get my a plus b squared is a squared plus 2ab plus b squared. So I'm going to get twice -2 times h, which is -4 times h. Then I'm going to get plus b squared, which in this case is h squared. And then I have my -4. That'll cancel. This will sort of happen every time. And now I divide by h, and I'm going to get negative 4 plus h. Now, let h go to 0, gives slope negative 4 at the point negative 2, comma 4. And that's the correct answer. So the slope of the actual tangent line here, I'll draw it in red, would be very steeply negative. If I step 1 to the right, I have to step 4 down in order to stay on that straight line, and that's a slope of negative 4. Okay, so that's how we do it. We sort of let the points on the curve approach the point we're interested in, and now you can practice by computing for this curve the slope at this point, for this curve the slope at this point, etc. For this curve at this point, you'll have to do a plus b to the third, which will be a to the third plus 3a squared b plus 3ab squared plus b to the third. Okay, good luck. Practice this yourself and check the answers in the back of the book.